Hi everyone, we're live. My name is Alex Live, and you're watching the GraalVM Streaming Week episode. I can hear myself talking, which is a good sign. And this is my pleasure to introduce our guest today, who is a very interesting person and who is a person that has a lot of experience in the industry, in specifically the Java industry, and also across a magnitude of other languages and ecosystems, and has been a tremendous asset for anyone who wanted to learn from the best. So without further ado, let me introduce our guest. This is Ted Neward. Ted, how are you doing?
I'm doing okay. Oleg, how are you doing?
I'm pretty good. Estonia got a sudden increase of summer weather last week, so
Yay!
it's been good. The situations with the viruses here kind of normalized a little bit more as well. So hopefully we can proceed with that across the world.
Yeah, it is a lovely gray day here in Seattle. Stays lovely. Oh, sorry, did I say that out loud? Anyway, yeah, it's a lovely Seattle morning out this way. So, and glad to hear that the virus is letting up on you guys. That is welcome news. Welcome news indeed. So, so you wanted to talk about Graal, right?
Yes, in general about the Java ecosystem, a little bit about GraalVM. I've seen a couple of tweets of you recently that suggest that you kind of sort of keeping an eye on the project. And I would like to chat like in general about maybe the ecosystem of Java, right? And I know that you normally you would be participating in various conferences and kind of sharing your experience and your point of view on architecture and the developer culture, and how we should build software, and how developers should grow their careers, and like a lot of different topics worldwide, right? But this year was kind of a little bit strange, so maybe you can give us a little bit of insight what you've been up to like recently, any interesting projects. In general, how much have you been working with the Java and Java ecosystem, just to set up the stage a little bit?
So about 2 years ago, I joined these guys, which is Rocket Technology is the technology division inside of Quicken Loans, who is on the verge of rebranding themselves as Rocket Mortgage. So we're Rocket everything. We have a bunch of different companies that are part of the same family of companies: Rocket Homes, Rocket Auto, et cetera. And originally I joined the group as a director of platform strategy, thinking about how we want to take the technology platform into the next, into the next millennium, the next generation, the next whatever. And while I was there, after a couple of months, some interesting things happened. Most notably that my leader, my boss, Brian Woodring, as he was moving into the CIO role, he said, I noticed that you're spending a lot of time talking with people about, how do we interview? How do we mentor? How do we know what, our team members, how do we know that we are helping them grow in their careers? What sort of educational resources do we have for them, et cetera, et cetera? He said, it's interesting. I'm not paying you to do that. What happens when I pay you to do that? And I said, okay, challenge accepted. So for the last year and month or two, I've been running an entirely new group inside of Rocket Technology called Technology Culture, where we focus on the people in people, process, and technology. So to be really honest, from a Java platform perspective, I haven't been up to a whole lot directly. I mean, I still keep my hand in it. I follow some of the Graal releases. I've actually been playing around with Graal as a Polyglot host for a couple of interesting side projects that I'm working on. But in all fairness, I can't say that I've really been all that deeply involved in the Java ecosystem except as an observer. which is itself an interesting place to be. I'm loving watching Kotlin grow more of its native mindset, if you will, and I'm loving watching some of the conversations that are going on. And I'm still engaged with a lot of the people involved in the Java ecosystem. We just had a meeting yesterday for DevOps UK, and I'm part of the track chair there. So it's definitely interesting. And I can certainly speak to the outsider, but if you were to ask me what's the latest, greatest version of the Spring framework, I have no idea. Micronaut, Spring, they've all grown distant in on the horizon. Because in some respects, my years of being a part of the ecosystem, my years of being a developer, have taught me that any particular framework version number doesn't really matter. It's more the concepts and the trends that will really shape the next 5 to 10 years. And so that's a lot of what I've been thinking about, is a lot of that very high level perspective, which sounds super pretentious, but hey, I'm in management now, so pretentiousness is kind of par for the course. You have to be a little bit if you want to feel like you have the ability to suggest to people which direction they should go. So it's been interesting. It's been fun. It's definitely an entirely different set of problems than a software architecture has, and yet in some ways the problems are similar and related. In many respects, you're both doing, as both as a technical architect and to some degree as a human architect, you're dealing with a lot of the same problems. How do we arrange parts on the canvas? How do those parts communicate with one another? How do I notice when there are blockers between the parts? And how do I influence the outcome in some way to make it flow more effectively and so forth? The problem with human architecting is the fact that humans are intrinsically non-deterministic creatures. So in some ways, software architecture is a lot simpler. And I realize that I am offending people left and right who are probably listening to this, but from having done both now I was an architect for 10 years, and I've been a manager now for 5. There's a lot of similarities, and it has a huge amount of rewards if you want to stick with it, but it by virtue of the fact that humans are non-deterministic, it's harder. By the fact that humans are frequently self-driven, it's also a lot easier, because in some cases I can just say, hey, team over here, you see that over there? Go get it. And if that team is up for it, if you've sold them on that vision, they'll charge, and you don't have to oversee the process anymore. Whereas in software architecture, you have to think about every aspect until people start writing code. So it's harder and easier. It's a different set of challenges, and I'm loving it. I'm absolutely loving it. And I swear that's not the implant at the base of my neck talking. I swear.
Yeah, you've moved to the management, right? But like what you mentioned, a very interesting point there is that both for the human manager, for the team manager, right, and for the architect, you need to be sort of a visionary in a sense. Yep. You have to predict and organize the work in a way that whatever the outcome is, it can be evolved to answer to the questions that will come up and just later, right? So you have to be kind of solving tomorrow's problems, or at least anticipating tomorrow's problems. So
you have to be taking a good stab at it, right? I mean, the thing about the future is, it's ridiculously hard to predict. You can't know ahead of time what's going to happen. I mean, for example, there's no way we could have predicted the pandemic. There's just no way. I mean, by the time January and February of last year rolled around, certain people were looking at it and going, I'm concerned, we're nervous, but there's no way from a perspective of a year or further out that you could predict that was going to be a thing. And as a result, you could not predict, for example, the ridiculously hot real estate market that erupted out of it. And truthfully, I'm still surprised by it. At least in the US, all of a sudden housing prices went through the roof. Our business, the mortgage business, it felt like it doubled overnight. I mean, it was just, at a time when we were being told shelter in place, the idea that somebody would want to pick up and move that place was just astounding to me personally. Now, maybe other people can go back and point to things that they said, oh yeah, we saw the pandemic coming a year ago, and we knew that it would have these, ripple effects throughout the rest of the system. Because that's the thing is, both humans and software are systems, and you really need to think about them as systems. And systems are intrinsically difficult to predict. And so part of what you're doing, very bluntly, is you're making bets about what you think will be the right thing to come down the road. And the thing about bets is you can't ever know for certain. There is no such thing as a sure bet. It's not even a sure thing that the sun will rise tomorrow. It's a very, very, very strong likelihood that it will, but we can't know that because we certainly don't control the inputs into the process, and we certainly don't control all of the inputs into the process. So as a manager, part of what you're doing is you're looking at the established landscape, and you're trying to see kind of what trends are rising, what trends are dropping, and make bets based on that. In the same way that an architect looks at the technology landscape and sees the things that are rising and sees the things that are falling and makes bets based on that. And you decide from there, where we want to go, right? Node and Python certainly have become very, very popular. Does this indicate that this is a rise in general around dynamic languages? And if Python is still, last time I checked, if it was still the most popular language for learning things, certainly no offense to Java and the JVM, but if hordes of people are coming out of boot camps knowing Python and Node, how do I incorporate that into my technical architecture? How do I take advantage of that? Because as a manager, part of what I need to think about is human, right? Is my staffing needs and my future direction as my project grows and requires maintenance and so forth. And frankly, if I have to go and staff my team with nothing but senior software engineers who know, everything about the Java environment, it's going to take me 5 years to staff my team all the way. I really need to make sure that I am staffing my team so that mid-range engineers and entry-level engineers can be a part of that team. And so, for example, does it make sense for those entry-level engineers to be using a dynamic language while the rest of my team uses a static language? Or do I have my senior working in something like Java or Scala or Clojure? And I have my juniors starting with Python, moving to Groovy, et cetera, so that as they grow and as they become more comfortable with static type systems, blah, blah, blah. Or perhaps you have the opposite opinion. Perhaps you believe that dynamic languages are actually harder to reason about. You can kind of see how all of this stuff starts to tie together, right? And it all becomes a bet. And so you have to be comfortable making those bets. So that's one area that's very, very common to both architect and software engineer. And each learning a little bit of what the other does really, really helps. It really benefits. Because then managers can understand the technical discussions that their team are having. And architects can understand some of the conversations that managers are having with other managers around the team and with their superiors and so forth and so on. Yeah.
Right.
Yeah.
So, sorry, you said that you see more and more people, specifically the entry level or like people coming off boot camps or students come with some background in Node.js and Python in those dynamic languages. Do you see at the same time some sort of a decrease of Java specialists like on the market in general, or is it just the rising tide sort of rising all boats, as they say? It's just the
It's
number of engineers. Both. A little bit both.
Yeah, it's really a little bit of both. On the one hand, we're getting a huge influx of people from these various boot camps, and they're not learning Java. They're learning JavaScript or they're learning Python at these various boot camps. Now, That's no knock on Java per se, because they're not learning C# either, unless it's a company specific bootcamp. They're not learning, the .NET platform any more than they're learning the JVM. For whatever reason, Python has captured the popular imagination as the platform that's easier to learn over some of the other ones that are out there. Part of that, I think, has to do with Python's relationship to the academic community. Part of it, I think, has to do with Python's relationship to the big data and AI machine learning community, which, by the way, came out of the academic community. So I have a feeling those two are intertwined. The bigger question, and I think the more important question, is, do we see a drop in the number of Java specialists out there? No, but at the same time, I think we're seeing a drop in the number of specialists, period. I mean, one of the things that I think is true of any company you go work at, especially if it's not a company that's selling a particular platform, right? Inside of Oracle, this may not be true in the same way that I don't think it's true inside of Microsoft. But when you get to, the companies out there that are using these languages and platforms that are created by those two companies, you find that it's very, very polyglot. You're often building a full feature slice, if you will, through the platform. And so you're building your backend perhaps in Java or C#. You're building your front end in JavaScript or TypeScript if it's a web application. You're working with a SQL database or a NoSQL database perhaps, but there's usually some sort of language, or it's GraphQL, right, that you're actually querying and so forth. And then, of course, there's the inevitable web, HTML, CSS that you need to, so you're already being kind of shunted into this polyglot perspective. And to be blunt, that doesn't make a whole lot of room for people who are Java specialists. The era, in some ways, of the fully server-generated web application is probably over. The idea of JSPs generating the HTML, including the JavaScript, et cetera. I mean, it's really, it's really a case of, we want that interactivity on the browser side. We theoretically, we need that interactivity on the browser side. We're desperately trying to turn the browser into a generic application host, which has its own interesting implications. And so as a result, the browser has to be done in something that the browser supports, which isn't Java, isn't C#, isn't Python, it's JavaScript, and now hopefully WebAssembly, right? If that initiative, gains any weight, gains any traction to it. And as a result, you kind of have to be polyglot. And that means that there are so many different places where you could specialize. And a team of specialists in some respects doesn't really make a lot of sense for a company that's using these tools. Maybe having one or two specialists within the organization to handle each particular area, that makes sense if you're of large enough size. But when you use the term Java specialist, it's like, well, if by that you mean somebody who's generally capable of building a web application on top of the Java platform, yeah, I don't see that going away. If you talk about somebody who really understands, the nuts and bolts of how reflection works internally inside of the JVM, yeah, there's not a lot of those on the market.
Yeah. I think the software development gets more applied than ever before, right? What you said, very interesting thing, right? You said so people and teams and projects are becoming polyglot. So now there's a direct segue into the GraalVM discussion. Do you think the runtimes should become also polyglot, or does having a polyglot runtime benefit in any particular case? Because GraalVM you can use specific, and my question is directly about GraalVM, of course, right? You can use GraalVM as a faster JDK, right? You can run it, the JIT compiler will optimize eventually the code, you will have better performance, you will save some electricity. Maybe if you are a company of a Twitter size, then you don't have to build an extra data center just now, but you can postpone that until later. So all that good. But the polyglot aspect, right? Do we need, how much value does it add? Do you think it's interesting? Will it take off? What's your...
Oh, it's huge. It's absolutely huge, in my opinion. Because here's the thing, we keep running into these debates. Remember back in the day when Groovy was first coming out, And we had, these great debates, Ruby versus Java, Groovy versus Java, dynamic versus static. And there are advantages to operating in a statically typed environment. There are advantages to operating in a dynamically typed environment. And we could go through all of the different technical arguments one way or the other. The dynamic environments tend to have a little bit more flexibility. They tend to give you a little bit more room to do some interesting things that the compiler will otherwise create a lot of heartache for, right? I mean, some of the earliest unit testing frameworks were built off of dynamic concepts. The idea that I'm going to scan a class, I'm going to look for the names of, methods. And if the name began with test, I'm going to execute it. I'm going to treat that as a test method. That's a very dynamic concept, really. In a lot of cases, when we talk about dynamic, a large part of that is really the notion of name-based binding as opposed to signature-based binding that's decided up front. And that represents some really intriguing power and capability. The flip side of it is, if I typo the name in a string, then stuff blows up. And that's where the statically typed folks are going to say, yeah, see, your code is less reliable. You have to write more tests. This is the part where I really want to bring up that meme from the taco shell commercial where the little girl says, why not both? And realistically speaking, I think that represents a huge, huge area of unexplored goodness, because there are a number of advantages to having a dynamically typed environment. This is the notion of a scripting language, things like the Bash shell language or PowerShell that can take disparate parts and glue them together in a way that the original creators of those parts hadn't anticipated. I mean, at the end of the day, really what we need to be thinking about as developers is not how do I force all of the work to come through the development department? Because yes, that certainly helps make sure that I remain employed, but it also means that these projects now start to take years to execute. And I don't know if anybody paid attention, but the business world has a tendency to shift drastically. Again, I go back to a year and some months ago when we all suddenly were facing a pandemic and had to work from home. And all of a sudden, Uber watched its business go from giving people rides to giving bags of food rides, right? I mean, there was a huge, huge shift in terms of their demand. And if you as a business can't respond like that, right? If you can't pivot that quickly, you're going to go out of business, as many, many businesses did. And that kind of whirlwind of destruction that comes through also creates a lot of opportunities, which means you have to have the ability to create and develop things more quickly. And if your IT department is saying, oh yeah, that epic will take 12 months for us to execute on, you've lost. So how do we create platforms? How do we create things that people can build on top of? And by people here, I literally mean some of the other business folks inside your company. How do we give them the ability to do things? I'm going to actually go back to some examples that may give some people nightmares, but I don't care, because the point, you think about the Microsoft Office and Visual Basic for applications. That was a scripting language that sat on top of this very, very powerful platform that enabled a whole slew of things, including a virus, by the way. For those who don't remember, one of the earliest viruses was actually carried as a VB script through Microsoft Outlook, because Outlook was in the spirit of trying to give people the ability to do some amazing things. Outlook said, if you attach VBS, we'll execute it inside of every client mailbox. Okay, that may have been going a little too far. Thank you for that, Microsoft. But it really proves the point that when you can give people the opportunity to do some things on top of this platform, some of your listeners may remember Ola Beanie from many, many years ago. Ola was a thought worker for many years, was very interested in languages, and he had a blog post. I don't know if it's even still up, but he had a blog post where he talked about sort of the pyramid of languages, where you often, as you get closer and closer to the metals, you get closer down the stack, the more you want static typing discipline to be able to support and guarantee what you're doing. The closer to the top of the pyramid, the more you actually want dynamism and the ability to work flexibly. And Ola would certainly know. I mean, he has He has lived his life inside of the JRuby world and therefore the Ruby language, but he's also lived his life inside of the JVM world and therefore Java in its statically typed environment. And as a result, that pyramid, right, is really something that I think we don't think a lot about in terms of capabilities and in terms of power. So to me, the polyglot thing is absolutely crucial because now I can take those newcomers, those people who know Node, those people who know Python, and I can take them, have them write code in languages that they are comfortable with and run it on top of the same JVM that I'm using to execute my Java baseline. Ironically, this is the same promise that Microsoft made initially with .NET, and I loved it just as much there. They've since kind of wandered away from that to, oh, well, C# is kind of the one true language for the .NET platform. But they've also got a number of other languages there. And quite honestly, I wish that they would invest a little bit more in the notion of what we see with a Graal. And I think they are, but not quite as publicly and not quite as emphatically. But we do have like PowerShell, which is actually running on top of the CLR. So I could write things in PowerShell and then use it to run .NET assemblies and so forth. And I really think that inside that space, inside that polyglot of, dynamic at the top, static at the bottom, just as a basic example, yields a huge amount of flexibility and power, even to the point where if I build my user interface, for example, inside of JavaScript, and then that source is interpreted on the end user's machine, for example, that gives that end user the opportunity to go in and literally tinker with that source on their machine and customize their UI to how they want to work. And now that doesn't have to flow through the IT change board process, et cetera. You have to put a sandbox around it, don't get me wrong. It's never just that easy. But think about the power there, man. Think about the power that you can now deliver to your users to say, yeah, if you understand this language, be it Node or be it Python, and then you want to start tinkering with the applications that we've given you, there's still some parts that we need to make sure work. Business logic that needs to be guaranteed, for example, continues to reside on the server, blah, 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 blah. Oh, man. I mean, that kind of responsiveness, that kind of engagement, that's just, oh, man, that's huge. That's huge.
Right. And I have the Ole Bini's blog post here found and showing to the users called Fractal Programming from back 2008. Right?
Yep.
And it talks
this
about
the
polyglot
concept.
systems. And it's very interesting. What you said there is that you can allow people to customize some JavaScript. That's also kind of sort of a very interesting use case. One of the maybe more known usages of GraalVM. There is a project called NetSuite in Oracle, which is an ERP, I think. This is like a suite of software for your businesses, right? Like sales, marketing, and all in one. And it's written in Java, and it allows you to customize your instance running somewhere in the cloud using the third-party JavaScript apps. And I don't know fully the details, but I assume that it allows you to customize the UI, what you see in the browser. That's the easy part because that is served specifically to you, right, or to the particular client. But it also allows you to customize the business logic on the back end using JavaScript, which is powered by GraalVM. So that is cool. And then the other thing that you mentioned, this power of those dynamic, a simple language based, or like some sort of language that gives power to people who are not actually developers by their profession, sort of like Microsoft Excel and spreadsheets gave power to the Visual Basic scripts, and then that powered everything, right? To this day, they say that the biggest competitor to your software, whatever you're doing, is either email or spreadsheets, right? So that's that. Similarly, there is this use case of, I think it's called Apex, which is the platform for
it's
a
Salesforce.
low-code platform. No, I think it's Oracle. So it's Apex, GraalVM. Apex is also a game, but there is a sort of Apex is a platform that gives you a database, right? And then in that database, you can execute JavaScript on the server side. So with a very simple interface, with very little code, you can manage your data
Yeah.
very closely to where it resides. So you can be like a product manager or somebody who's not actually writing and building software, as we know, with all the necessary operation stuff in, right? But you can just write a little bit of a script that works a little bit with your data and then have the fully featured web application running there. And JavaScript there is also powered by GraalVM. So that is very cool. And
yeah, yeah, I think that we see, this notion of giving me a platform and then giving me something on top of that platform that I can use to customize its behavior. That's absolutely huge and powerful. And it's interesting that you mention spreadsheets as being one, the great competitor to your application. I worked for Smartsheet for a couple of years prior to coming over to Quicken Loans. And Smartsheet was literally born out of the idea of how do we make it easier to, how do we solve the problem of people emailing spreadsheets around, right? In terms of project coordination and whatnot. So there you're combining both of your mortal enemies, email and spreadsheets, into a single entity. And yeah, in many cases, if your software is too difficult or if it doesn't do exactly what somebody wants it to do, they will fall back to what they can do, which frequently is email and spreadsheets or access databases, right? That was the other thing for many years, was I'll spin up an access database or a Visual Fox Pro, same idea, different vendor until Microsoft bought them. But if you're not solving, the key message here is if you aren't solving your users' problems, they will find a way. They will work around you, and you may not like what they come up with. And you may find then that you have to create an application that replicates what they've done. So now you have to figure out a way to automate sending email spreadsheets through email and parsing them. Nobody wants that. Nobody wants to do that.
Yes. So yes, I wholeheartedly agree, and that makes me very, very happy to know that you also think that Polyglot is a big part of the future. Like, talking about the future, actually. So I read your blog, before coming to this meeting, right? And you have those prediction blog posts,
yep.
Right? And you had one for the past year. I didn't read that fully. I don't think you predicted the what actually happened in 2020.
Nope.
But you have the predictions for 2021, right? And one particular there is about the languages of platforms that will march on and nobody will care, right? Which you kind of sort of touched on that. There were like, people need to solve the business problems, and the particular details of how they do, whether that is the latest particular application framework like Spring or Micronaut, or the particular details of the language syntax are not important, right? But since I would like to talk a little bit about Java. Do you have a favorite, the favorite project that is going on in the Java ecosystem in the, say, OpenJDK? Is there anything that you think would kind of not revolutionize, but be a very big enabler for the things that we cannot do or hardly are doing now? I don't know.
So, honestly, my favorite project inside the Java ecosystem right now is Graal, because I think it's at the core. I think it is, a lot of the Java library projects, and really, I should say a lot of the JVM library projects, including Spring and so forth, they're useful in certain scenarios, but it's not something that you would use everywhere. For example, I'm not going to use Spring if I start building a game using libgdx or something to run on top of iOS and Android, etc. But Graal certainly has potential there, for example, using some of its ahead of time compilation capabilities to do, in some respects, what Kotlin native is talking about doing, pre-compiling a Java application into ARM assembly language so that it can run natively on top of iOS or Android, depending on what the underlying processor is. There's a lot of really, really interesting possibilities that have opened up thanks to Graal. And in many respects, the various frameworks, they will continue to march on. They will continue to develop. They will continue to add some interesting features, which will be interesting to the people who are heavily invested in those things. But I can't say that I'm really tracking them, all that closely, simply because to me, it's more of the same for 98%, 99% of the things that they're doing. Now, there have been some suggestions of things to do to the JVM. I really don't care what Brian Getz does to the language. I love Brian. Brian is a friend. Brian and I spoke together for years on the No Just platform. He can be cantankerous as hell, but at the same time, he's wickedly smart, and he is what the Java language needs right now in many respects. A willingness to break eggs, but not until we've gone and done a whole lot of review and investigation and research to know exactly which eggs we will break and how they will break and how people could migrate, etc. Brian is exactly what the language needs right now. But the language, frankly, is boring. The language doesn't really do anything for me, period, because we've demonstrated already that most of the really interesting language development is happening in these other places. So I care about the things that are actually affecting the JVM. And I forget which project it was. I think it's Loom is the idea that's introducing fibers, lightweight threads into the JVM, right? That one I care a great deal about, because that would allow the JVM to do some of the things that we have asked it to do through various library projects, which is to try to replicate a lot of what happens inside of Erlang, which is to say we have, their processes are essentially what we're calling fibers inside of Loom, or lightweight processes is what the Unix world called them for a while, lightweight threads. I mean, the funny thing is what we're talking about here is the degree of support from the underlying operating system for the internal data structures of how we separate, execution. There was a proposal way back in the JDK 1.5 timeframe called isolates, which were intended to allow different portions of the JVM to be essentially segmented off from one another. So that crossing an isolate boundary, I almost said app domain, because that's the equivalent concept over in the .NET world. Crossing an isolate is actually like crossing a process barrier. So you have to serialize and deserialize whatever you're passing across the barrier. This was intended as a way to help JVMs be more resilient, rather than have like one native thing cause the whole thing to die, blah, 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 blah. Isolates never got off the ground, unfortunately. In the .NET world, we've had app domains for, since the very beginning, and .NET is actually in the process of removing them from .NET Core. And, it's interesting to see. I think today, rather than try to do that isolation boundary inside the JVM or the CLR, we're actually choosing to do it outside by making a Docker image around the instance of the running JVM, so that we're pushing the JVM boundaries out literally to the edges of the virtual machine. All right, fine. If you want to do it that way, we can. There's some overhead that comes with that, but we can make it work. Those kinds of updates, those kinds of things are the things that I'm really, really interested in. The next step in some ways would be if somebody were to create a project whereby we could actually add some of our own fundamental capabilities to the JVM. And I'm thinking like add a new bytecode, right? Look at how much time and energy it took for us to put invoke dynamic into the JVM. And I don't begrudge that time or energy. I think that's huge, but that would be one of those things that would allow me to take the JVM, fork it, introduce something that could then be JIT compiled, because I need that level of performance. Think about your trading platforms, the people who are doing these massive amounts of mathematical calculations that they need to be done in split second, right? The reason why most of the people doing currency arbitrage are using a language called OCaml is because it compiles into native code, which they say gives them that extra half second of performance over their competitors, which allows them to be more successful. If you could give me the ability to add a new bytecode into the JVM, which also means then I have to have a language that's capable of emitting that bytecode, that would then give me the opportunity to emit something into, native code without having to go necessarily the whole JNI route, and it could be just incorporated in my language. Now, you might say, well, what if we make it easier just for you to do something native? I know Brian has talked over Twitter about he's starting to look at a way to replace JNI. Great, that would be welcome. Would love to see us do that. But the whole point there is you're now really opening up the JVM again to some opportunities for me to customize it safely on the behalf of the kinds of applications that I build. That would be huge. Those are the kinds of things that I think really matter, because those are the game changers. The other stuff, truthfully, if you wanted to replace Spring with something else, would your users really notice? I doubt it. I really do. If you wanted to replace the use of Micronaut, or if you wanted to change your ORM, or a lot of those other things, those are ways in which we make other things happen. The game changers are happening much further down in the stack, in my opinion. So, yeah.
Those are implementation details. That's interesting, right? So I've heard a lot of people talking or waiting about Project Loom, which is exactly the lightweight threads, or whatever the correct name for that is, the fibers, as a game changer. And yeah, personally, I would absolutely love it to be shipped as soon as possible, but we will get it when it's done, of course. And then, the project, I think it's called Project Panama, where you can link to the native libraries a little bit differently than through JNI. And I think that one is being delivered piecewise. So this JDK, Java Evolution Cadence, has been increased a couple of years back, right? And then now from the Project Panama, we have like a number of JEPs that have been delivered. I don't think it's fully has built the picture how to do that yet for the end user applications, but there has been quite a bit of progress. And then you mentioned isolates. Do you happen to know which project has the isolates technology sort of available?
No.
There's in the GraalVM Enterprise Edition, when you build a native image, you can enable isolates. And then when you build a native image, right, you sort of, what it does, it runs your application a little bit, right? And then it initializes that, and then it writes it out with the image heap, with the initialized data in your application. That is one of the things that allows it in this incredible startup performance, because not just your code is compiled, but you also, the data that you want to use is initialized and written out in the image heap, right? And then you can have multiple isolates that will have the read-only access to this initial image heap, and then they'll have their own chunk of memory. And then they will do the computation in that memory, and then you can just discard that, which is very cool. Yeah.
You know what's fascinating about that, when you talk about the image heap, where we get that term actually comes from Smalltalk and other related languages like Self, which had been doing things like this. And in Smalltalk for years, it's been capable, because you build your code inside of a Smalltalk browser and you run your code inside of that browser. That is your environment. You can swizzle that entire environment off the disk. And frequently that is the definition of a Smalltalk application. So that when you run it, what you're doing is you're deserializing that image heap and bringing it into play. Both of these are dynamic languages. Both of these are capabilities that have been a part of those environments for literally decades. And I have often thought it would be extraordinarily cool if the JVM could do something similar, so that, for example, an exception occurs and it isn't handled all the way. So you get to the top level exception handler, and you literally have a handler there that says, you know what? Dump the whole image to disk. Tag it with a timestamp file name, send an email to a developer with the image as an attachment, and let them debug it on their own machine. I mean, suddenly the whole need for application logs starts to fall away as a debugging tool. You still want it as an analysis tool to kind of see how your application is running, but as a debugging in the moment, if you could swizzle the entire JVM down to disk, right, or the isolate in this case down to disk, and then rehydrate it and have breakpoints set and so forth. Just think about how useful that would be. I mean, just,
Yes.
oh my
Yes.
gosh.
It's a little bit hard to maybe implement that with the like JVM heaps of like hundreds of gigabytes large, right? Because historically we run JVM when we want like as a massive process as possible to utilize all the resources. But if we kind of make it smaller and isolated, then that perhaps could be a very interesting idea.
Yeah. Well, I mean, if you're running a JVM that's hundreds of gigabytes in size, you may have other problems, right?
Oh,
And you
absolutely.
may, you're going to run into a bunch of other issues. And frankly, the growth of the microservices effort, right? The idea of let's break these out into smaller pieces that can be run independently. Now it's not hundreds of gigabytes. Now maybe it's one or two, or maybe 8, or even 16 or 32. These are all still reasonable file sizes, particularly if, I'm not actually attaching them in an email, but I'm attaching a link to them on some secure file share, right? Whether that's up in an S3 bucket or whether that's, on an on-prem file sharing service, depending upon whether you're running in the cloud or on-prem or what have you. Even a 32 gig, I mean, if the JVM is 32 gigs, a lot of that will be some internal bookkeeping from the JVM that we don't need to capture as part of the heap, because a lot of that could be rehydrated and reconstituted. What I need is the data that's stored in those objects. I don't need the actual object locations. I don't need, the JIT compiled methods and so forth. What I need is essentially the hot and cold data. And so I suspect you could probably trim that by 50% by not including that. The hard part will definitely be where the JVM touches native code directly, right? There will be, if your code for whatever reason calls out to a native connection, right? You're going over the Oracle JDBC connector to talk to the Oracle database, and that is using some native code. Okay. I certainly hope there's no application state in that native code. That should be something that we can hydrate when we rehydrate everything, when we instantiate these things. But B, if you did have native code, even there could be ways, if you conformed to a particular protocol that the JVM established. Look, I ain't saying this would be easy for the JVM engineers to build, don't get me wrong. It would represent a huge engineering effort, particularly to try to retrofit it on top of the JVM 25 years later. But that is one area of software archaeology. When you go back and look at some of the things that Smalltalk and Self have enabled, right, the ability to do some of this stuff. And it is an interesting area of academic research. There have been a couple of people who've done some papers around, ideas to be able to do similar kinds of things. A lot of the early object persistence efforts, for example, were very much around the idea of, well, let's just swizzle this object to disk. Okay, cool. If we can do that, then let's just swizzle this entire object graph to disk. And if we can do that, then if I can get all of my data and state stored in that one graph, then taking it and putting it to, it won't necessarily give us exception stack traces, but that in of itself offers up some interesting ideas. And, this is one of those features that I don't think any Java engineer is ever going to email Brian and say, I really want you to do this. But doing that would be a huge game changer for the platform. And so that's, that kind of goes back to I don't really care what they do with the Java language. I don't really care about the various library platforms. I care about what's happening at the JVM level in that respect. And I say that for both the JVM and the CLR and the Python platform and the Ruby platform, all of those platforms, there are some really, really interesting opportunities there, to do some of the things like you're talking about, like Graal does with that, that initialization, bootstrapping, storing off that as the read-only heap, and then working from there. Obviously, you can't go too far down the application startup process, but doing so would absolutely spin things up faster. Because the one thing that we have discovered is drive space is pretty cheap. I mean, drives just keep doubling in size every 18 months. So yeah, if you want to store a 1 gigabyte native image on my phone and make it easier for me to, get a phone call that quickly, I'll take it. I'll absolutely take it, because I got I got 128 gigs on my phone, of which maybe 90 are just empty space. So
yeah, yeah. No, the resources that hardware has are like, I don't think even like 10 years ago, where the whole concept of cloud has been starting, that we could envision this growth, right? Like you mentioned Uber application is a little bit less than 400 megabytes, like, and nobody bats an eye, right? And that's an incredible amount of space. Like, you can probably send like a whole fleet of rockets to moon and back, using that amount of resource and computational power of a phone, right? But here we are. So, and then on the cloud, you can, like, the cloud providers can probably add the disks to the clusters faster than you can write data to those disks, right? And then you will run out of money if faster than they will run out of the hardware.
yeah,
So that is interesting, and that is interesting. I really enjoyed your sort of this vision that maybe the runtime can help us with the debuggability of our applications in this new kind of old but new way for the Java platform. Maybe it requires some additional level of virtualization that is currently not possible. That is something that is very interesting to think about.
yeah,
Right.
yeah.
Thank you very much, Ted. I know that you have
You're
a
welcome.
hard stop in a couple of minutes.
I do.
I enjoyed our chat. I hope this was insightful for people watching us live or people watching us later on YouTube. And if you have any questions to Ted, I'm sure he would be happy to chat with you. You can find him at Ted Neward on Twitter. That could be one source how to reach out to him, or there is a plenty of data how to find Ted. Otherwise, for example, about me/Ted Neward, and then take it from there. Thank you very much, Ted.
Thank you, Oleg. It's been a pleasure.
It's been excellent. If you're watching us live, then the next stream this week will be on Thursday, and we're going to talk about Java and Python and running Python applications from within Java apps, of course, using GraalVM. So yeah, tune in for that, and thank you very much.